All right, so let's talk about data design. Let's start with a trivial example. Yes, you have you can upload a PDF or link it if you have on Git. You can then link it from your repository and then link it there. Yeah, you draw the UML. There's a couple of tools that I will link that are freely available. There are a whole bunch of online tools, or you can download and use on your desktop. I'll point to a couple of them. Yeah. All right, so let's talk about data design. We'll talk about a really trivial example of a very, really simple schema. And then you say you want to get started on cataloging your CD collection. And a really trivial way to get started is to say, well, I know the CDs have title, the year they were released, the genre, the band, the you also have, well, a CD might have multiple tracks, and that's as far as I want to go, right? The track might have the title of the song, which track it's in, right? With 1 through 10 or whatever, the duration of the track, and I know they're related somehow with one another, where the track might point to the CD that it belongs to. Right, so there's a really simple one-to-many relationship. Okay, and I start going through my CDs, and the database is perfect, right? My first take on this works with most of the CDs that I've gone through. So when I get to my, all the way to my 30th CD, it looks like I find one that says, "Oh no, this one is a compilation, of the best of my favorite bands." Right, so it's actually multiple records from different different movie songs from multiple years from different albums. So were released in different years, or something that I recorded myself, right? That might actually have multiple bands and multiple genres and multiple. It doesn't fit nicely into my schema, right? So you start finding all these examples that are edge cases, that don't nicely fit into my original schema, right? So for instance, best of CDs or CDs with songs from various bands, CDs with various genres or genre. So is it a genre per track? The performance and band is a burn your own CD. So you'll find all these edge cases that your nice schema did not take into account. So oftentimes it's not useful to get started at such a low level representation of the data, right? Of a schema. Oftentimes it's much easier if you start thinking about the structure of the data at a much higher level, right? It's not bogged down with some of the implementation details, such as foreign keys and primary keys, right? Those are all just noise that is part of the specific infrastructure that we chose to store our data, right? If this were JSON, then we wouldn't have that, right? If this were Java, it wouldn't have it either, right? It's just something that's peculiar to the relational model. So let's talk. We want to think about something that is even higher than any of those particular representations, and what we're going to be using is what I refer to as class diagrams, right? So class diagrams is a conceptual way of thinking about the data structure that does not it's not bogged down with any of the idiosyncrasies of any one particular technology or language. So class diagrams allow you to think about the problem, graphically, and it's very great, very good for designing, for the design part of your efforts. In particular, we're going to be using UML class diagrams, Unified Modeling Language. It's a graphical language that allows folks from all walks of life to be able to converse independently on what they might be familiar with, either Java, C#, with their database folks, or even non-technical folks, right? Can easily understand how these are related to one another. UML is obviously much more than just class diagrams. It's an entire family of diagrams is used widely in software engineering and even beyond. But we're going to focus mostly on UML class diagrams, sequence diagrams. We'll talk about those a little later, and use case analysis diagrams. Right, but we'll stick to just those three diagrams. There's plenty others, but these three we'll talk about. So here's the class diagram representation of the tables that we introduced in the previous section. Right, here are the students, the departments, the sections, the courses, the enrollments. One thing that you don't see here, right, are the primary keys and foreign keys. See that? They're not in here, right? You don't see any SID or DID or any of that. Okay, those are actually implied or are captured instead by these lines. So these lines that go between these boxes, right? The boxes themselves are the entities, right, or the concepts or things that we want to capture, and they have names. Know that they're all nouns, right? Students, enrollments, sections, courses, departments, and then all the attributes that describe each one of those, the types of data that we're capturing. Another thing that we left out, but would typically be here, is the data types of each one of these fields, right? That some things are strings, some things are numbers and whatnot. Okay, but definitely what's missing from here, and is deliberate, is that none of the primary keys and foreign keys are here. Okay, now that's as far as typically we would do, right? Is that we would not include deliberately not include foreign keys and primary keys, although we might often include them only for documentation purpose, right? Yes, we know that behind the scenes this is going to be stored in a relational database, yes, right? And we know that there's a primary key somewhere in here. We might include it only for documentation purposes, right? But for design purposes, we would leave it out. Okay, it would be the kosher thing to do, right? Not to include it, right? But again, for explanation, if we're talking to a DBA, we're talking to, depending on the audience that you're talking, you might include certain fields that you would normally not include. Yes, and that's all UML is, right? It's a tool for having conversations, for discussing these kinds of things. So notice that each one of these lines is labeled with numbers or stars and whatnot. Let's talk about these things. We refer to the, yes. Zero. Oh, you mean oh, yeah, yeah. No, you would not have zero attributes. Yeah, one or more attributes. Yeah, I think I was going to refer to the cardinality. Yeah, the cardinality, how many of instances of each is participating in a relationship, all have the pattern, some minimum to a maximum, and dot dot m, right? So for instance, these ones, these stars, these 0 dot dot 1, right? These are cardinalities. They'll have that pattern, although these are shortcuts, right? Where 1 is really 1 dot dot 1. The minimum is 1 and the maximum is 1. Okay. This star usually means a 0 dot dot star. Star means any number. Right? It could be any of these. It could be 0 or more. The other example here is 0 dot dot 1, meaning that's optional. Right? It could be there, it could not be there. Right? Maybe I have a reference, maybe I don't have a permit to park here at the university. So it's optional. So the more common ones are star, denotes 0 or more, which is a shorthand for 0 dot dot star. 1 is a shorthand for 1 dot dot 1. 1 and star and 0 dot dot 1 are the most common ones, and we refer to them as annotations. We annotate the ends, right? So here the way it's read is that there's one section. One section can be related to many enrollments, and then one student can be related to many enrollments. And this is the result of a reification, We reify this. Really, what we want to capture is that one student has a many-to-many relationship with, many students have a many relationship with many sections, right? So one student can be many sections, one section can have many students. So we could have just said, drawn a line and said star and star, right? But that can't be implemented in SQL, right? In SQL, you can't have a field that has many values, right? There's no such thing in SQL, yes? If this were JSON, it would be fine. If this were Java, that's fine. You have arrays, but no such thing in SQL. So the only option is to convert that line of many to many, right, into a mapping table, right, that says, hey, all those students are related to this one section, and this one section and these many sections, right, are related to that one student over there, right? So then you would have an entry, a record that would say, hey, all these students have the same section, or this one student has many sections, right? And you have many records capturing that. Make sense? All right, so having decided going from that one line to this mapping table is the reification. What else? There's also one-to-many. One course has many sections. One department can have many students. Yeah, so here are the more common ones: the one-to-many, one department, many students, right? One to star. You could have a one-to-one, right? That you have a student can have just one permit, and this one is an iffy, right? It could be argued that, well, if the student just has one permit, you could argue then you could just say, well, you could just then embed these fields as part of the student, right? Because they just belong to that one student. But again, perhaps you might decide to perhaps is more understandable that it has its own little concept in a separate table, right? So this is more understandable and say, yeah, it's one-to-one, but I want to track it in a separate table. Or it might be optional, 0, 1. I might have a foreign key, I might not have a foreign key. It might be null. I have no permits. I don't park at the college, right? So it's an optional, so it's nullable. Here's the many-to-many that hasn't been reified. Okay, where you have if the student could be enrolled in multiple departments, having multiple majors, right? They might have a many-to-many to a department. Obviously, this can't be implemented. It would have to be reified. This would have to be converted into an additional table here that points to both that have two one-to-manys. This many-to-many would be converted into two one-to-manys into some mapping table saying that this student is in all those departments, and this one department has all those students. Yes? So that's a many-to-many. The strength, whether we know exactly how many are participating, right? We say that we can say how strong do we feel about that relationship, right? If we know that there's only one of these participating, we say it's a strong relationship. I know there's this one student has one permit. I feel very strongly about that. But over here, if it's iffy, I don't know if it has a permit or not. We say it's a weak relationship. I don't know if it's related or not. Sometimes it has a permit, sometimes it doesn't. So we say it's a weak relationship, right? The same thing with this one. A department might have students, it might not have any students. Okay, so it's also considered a weak relationship. I know there's one department, but I don't know if there's any students. So we say that on this side, it's a strong relationship. We say that it is a weak relationship. Okay, again, some jargon. Yeah, so some relationship strength, weak, strong. So here's some of the more common ones: weak, strong, weak, or strong. Not necessarily just one. This could be 4, 2. This car has 4 doors, right? Then you know that exactly you have these many doors, these many whatever are participating in the relationship.